Moving out from the Sun, we have Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, Saturn, Uranus, and Neptune. It's the last 4 of those we're particularly interested in today, birthed as they were more than 4 billion years ago, out of an ancient disk of gas, dust, and debris around our star, the Sun, which in itself had also only just come into being. This was the beginning of all things for the solar system, and a starting point from which it raced outwards. Now, Neptune, the furthest planet from the Sun, is on average 2.8 billion miles away from it. But it's not as though the solar system ends at this far-off, icy checkpoint world. The most famous object beyond Neptune is Pluto, the one-time planet demoted to dwarf planet status in 2006. It's 3.6 billion miles away. But even then, we're still a huge distance away from the edge of the solar system. There's the rest of the Kuiper Belt, the scattered disk, and the Oort cloud to consider, spanning for not just billions, but trillions of miles out from the Sun. It's perhaps little wonder then that there's always been some suggestion that there could be more planets out there, traveling around our star, but completely out of sight. Part of the reason for theories toward a so-called Planet 9 is that the very earliest days of the solar system are still quite unknown to us. In general, we know that planets like Jupiter and Saturn formed and moved to their current positions, but the process for moving them to those positions has been something of a mystery. Why did they land precisely where they have done? Why are their orbits all different from one another's rather than alike, seeing as they will have seemingly shared a similar origin story? However, a recent study may provide the answers. Published in late April 2022 in the journal Nature, the multi-authored paper leads with the title Early Solar System Instability Triggered by Dispersal of the Gaseous Disk. It lays out a new model for how the gas and ice giants may have found their place in space, and the gaseous disk is key. The study refers to an episode of dynamical instability among the giant planets in the early creation of the solar system's orbital structure, but it reiterates that the cause and timing of that instability is unknown. By running countless simulations of that formative time, however, those behind the study appear to have revealed what really happened. The destinies of Jupiter, Saturn, Uranus, and Neptune were shaped when the gaseous disk dispersed, when it first thinned and spread out from the Sun. Imagine a newly ignited star burning away its early life in the middle of a fog of dust. That's our Sun, around 4.5 billion years ago. And gradually, it creates room for itself, pushing the fog of dust further and further away from it. It's as though the early planets, busy forming within that dust, are then marked off, one by one, as the disk breaches wider and wider distances, and so their orbital paths and evolutionary routes are set into motion. They're still crucially and fundamentally reliant on the Sun, of course, but it's like they've flown the nest, cosmologically speaking. We might still refer to this process as having instability, because the planet's final destinations are still difficult to determine. But the general nature of the early solar system now suddenly seems a whole lot less chaotic. There really is a neatness to how it unfolds, with the solar system systematically painted into life, something like clearing soap suds off a freshly cleaned window, or icing a cake from inside to out. While this is all very controlled and satisfying, however, where does the undiscovered planet come into it? There isn't a focus on Planet 9 in the Nature article itself, but those behind the study have since touched on the possible implications for it, including in a release by Michigan State University, where one of the researchers, Seth Jacobson, is based. Broadly speaking, as we know that there was instability during the early solar system, can we now say with confidence that we know everything that was born out of that? Probably not. No matter which model you follow for how the solar system ended up as it is right now, there's always room for surprises and unexpected developments in something so vast and enigmatic as an entire star system. Adding just one extra planet into the mix might feel, if anything, like the least that could happen. Among the simulations run for the study, there were variations tested with both 4 and 5 planets at the start of it. And results showed that, actually, there wasn't a great deal of difference in what happens next. The solar system up until Neptune ended up looking much the same, with or without that extra world to contend with. And in fact, it was found that having that extra planet might even improve the chances that the 4 other planets should remain, as we know they have. Clearly, as we don't currently know of a 5th gas giant and 9th solar system planet overall, the model has nothing to match its potential orbit to in the real world. But while estimates do vary, it's thought that if it does exist, it could be orbiting as far out as 50 billion miles from the Sun. Neptune, remember, sits just 3 billion miles away only. It means that if Planet 9 is out there, it will have had a radically different lifetime and journey to any of the other planets. Already, there are vast fundamental differences between, say, Mercury and Uranus, or Earth and Saturn, but those worlds are tightly packed next-door neighbors by comparison. Planet 9 would be so far removed from the rest of anything else in the solar system, a lonely but unique world that, really, it's very difficult to even imagine. As there are some theories that it could still exert a gravitational influence over the rest of the planets from wherever it is that it's hiding, it may be that it's truly massive, lurking on the edge, with the sun's light serving as just the faintest, tiniest sign that there's more going on in the solar system's center. Would life be possible on such a world? It's unlikely, based on what we currently search for in potentially hospitable planets. Naturally, it's a long, long way away from the Goldilocks zone for habitability, and most of everything about this place would likely be very un-Earth-like. Could Planet 9 ever cause us a problem then? There are theories toward that end, particularly in relation to the supposedly foretold Nibiru cataclysm, where it's said that, one day, an ancient planet could come crashing through the solar system, potentially striking and destroying Earth as it goes. However, most scientists never seriously entertain that possibility, and assure us that we can sleep soundly in the knowledge that we're not about to get blown out of the sky anytime soon. Nevertheless, most major scientific groups do acknowledge at least the possibility of Planet 9. NASA, for example, draws on research published by a team at Caltech in 2015 involving mathematical models that also seemingly show that an extra world is possible. NASA says that Planet 9, if it does exist, could have 10 times the mass of Earth, and it could take up to 20,000 Earth years for it to travel once around the Sun. That's how far out it could be. But the underlying reality is that Planet 9 still hasn't been directly observed. For now, we can say that studies like this most recent analysis of early solar system instability provide tantalizing hints of what's potentially out there. We're still waiting for definite evidence, but that's why scientists